We all know how good Python is for web scraping. I've built my channel around it. But I like to challenge things, and I want to share with you how good I think Go is for web scraping, but only in this specific case. Now, there is a Go web scraping framework called Collie, and it excels in HTML parsing and scraping. I want to share with you in this video how it works, how easy it is to write, how logical it lays itself out, how powerful it is, how quick it is. So let's get started, and I'll explain along as we go. Okay, so we have the skeleton built out. Now we have our package, which is our main package. I'm importing in Collie. That error will go away when we start using it. And I have my main function ready to start. So the first thing that we need to do is we need to create an instance of our Collie, which is collie.newCollector. This is what's going to allow us to do everything. So the main thing that I like about this is this c.onHTML and the way that this works. So what I can do is I can say that whenever we're on a page, we can do something whenever we find HTML with an element that matches the selector that we're going to give it. We can then do something with that. So I think we can actually like move through pages. We can select pieces of information to save, and we can just crawl through in that way. I think this is a really good approach of doing it, and I think that you'll like it as well if you haven't seen this before. So what I'm going to do here is I'm going to go ahead and say, well, this is going to be the selector for the next page. So let me just grab that and show you where that is if you're not familiar with this already. There's this next page button down here. We have li tag with a class next and then an a tag. So what we need to do is li.next. These are just CSS selectors, and then a. Then what we can do is we can tell it to do something. Now what I want to do when we find this next tag is I want to visit that URL. So I do c.visit, and then I'm going to say h.request, and I don't need that one, h.request, and then .absolute URL. And then we're going to say that because our H is actually representing that element that we found with that A tag, we just need to do h.attr to get the attribute from it of href. So this is basically saying that our H variable is representing this element. So if we wanted to find things underneath it, we can do h.child text or child attributes, but in this case, we're just going to do this one. Another thing that we can do is we can do c.onRequest. Now this is particularly useful because what we can do here is we can just see where the pages are, see what we're going and what we're doing. Or you could run any of this code under here inside this when you actually make that request. But I tend to use it just to format.print, println, and I'm just going to print out here something like visiting, and then we're going to give it r.url. So this is just going to print out the URL that we are visiting on that page. Very handy. You see it in other web scraping frameworks too. So before we think about grabbing any information, let's just grab this URL here and do c.visit again. And this is going to be the one that's going to start it. So we're going to do here. So I'm going to save this now. Now we're actually not collecting any information at all, but I'm going to do go run scraper.go, and we should see all of the pages come through. And this is basically us making a request and getting back every page that it finds. Notice we go through all the way to the end until we don't find this element, this li next a tag, so it stops after that. What we want to do now is we want to think about grabbing information. So we're going to do c.onHTML again. We're going to put our selector in there. We'll have our function again, all nice and neatly filled out. Thank you very much to GoPlease and NeoVim, which is the editor that I'm using, which is fantastic. You should definitely learn how to use it. And now we can actually do something with this information. So I'm going to go back to the website again. I'm just going to find what it is called. Product pod. So you can see on the left hand side how the whole thing's highlighted, and we want article class product pod. So this part's going to be very similar to any Python web scraping that you've done. So we'll do article product pod like this, and now we have the access to this element that we can do anything with. So I'm just going to show you. We'll do format.print line again, and what we're going to do is we're going to do h.child attribute. Okay, so we're going to say inside this element here, we're going to find the h3 tag, then the a tag underneath, and I'm going to tell you that I want the attribute that matches title. So I'll get rid of this blank line. So now if I save and run, every time we hit this element, we're going to go to the next page. But every time we find one of the elements, an element that matches this, we're going to run this code. So you can see how we don't need to do any loops or anything like that. It's all done for us. Let's just clear this up. So we should get at the end of this a load of names. And these are all of, you can see them all here. Loads and loads of book title names. So we can expand on this and we can basically then go ahead and fill this out to what we want. But before we do that, what I'm going to do is I'm going to create a struct, which is going to be what we're going to put our data into. So I'm going to call this one type item struct, like this. And this is where I'm going to define what information is going to go into this struct and the types that it is. So this is a strongly typed language. So if you're not used to this, you come from Python, this might seem like an extra step to you, but trust me, it's worth it and you will get used to it really quickly. So I'm just going to say, this is the information that we want. I'm just going to copy this over and explain it to you. There we go. So I've got one extra thing there. So all I've done is I've said there's going to be a link, name, price, and in stock. This is a little bit like defining a dictionary beforehand, but we're saying that each of these has to be a string. So if I tried to put something that wasn't a string into this struct, we would get an error. And the JSON part is for when at the end, we're going to move all of our data from this struct and we're going to marshal it into JSON format just so we can see it a bit clearer out at the end. And the names, the link, name, price under the JSON is just me saying what the JSON field is going to be called. So now I have this item struct. What I'm going to do is I'm going to create a items variable here and I'm going to say this is going to be equal to a slice of items. So this basically says that this items is like a blank list, is going to be a list of any of this item struct. So we can only put this item struct in here, but that's fine because that's what we're dealing with. So I'm going to remove this and I'm going to copy this over with all the selectors again. Let's put this in here. There we go. So these are just the elements here and the selector. So you notice that we've got child attribute for these two. That's me saying I want the href from that A tag. I want the title from that H3, then the A, and the child text is just the text from these two elements. Now we need to actually append this to our items list. So we do items.append, and you'll notice that when we append in Go, we do items, append, then items again, and then what we want to append it to. Right, so that's done now. So what I'm going to do is I'm just going to come down at the end and we'll do format.print line and items. So now when we run this, we should go through every single page, then pull all that information out, and at the end I'm going to get my items all spat out back at me. There we go. So it's a bit hard to read, but you can see here's the square bracket, which is the end of our slice, and here is one item with the information in. There's the link, the name, the price, and the stock value from that thing there. But I want to have this in JSON. We did that with the struct at the top. So I'm going to do, let's say, our data and error, because this JSON marshal is going to give us an error back if one exists. So we need to handle that. So we'll do JSON.marshal, and I'm going to do marshal indent, which is going to let me pass in my items slice and then say that I want it to look like this. This is just basically telling it how to indent the information, so it's just easier to read. I'm going to handle my error. So if error is not equal to nil, then we'll just do not that, thank you. We'll just log.fatal this error. Handle your errors properly, I suppose, is what I should say. And then we'll do fmt.print line, and I need the string representation of the data, because otherwise we will just get a load of bytes, load of numbers. So let's run it again, get this information back. And there we go, nicely printed all of the information that we've gathered. I'm going to copy some code over that I pulled out, that I didn't make up, obviously. I pulled it out of Stack Overflow. So thank you to whoever did that, and let me grab this. So what we can do now is we can actually time this. I should have imported in time at the top. Usually does that automatically. I just need to put in another line. We need to defer our timer, which we've just created, on our main function, like so. Great. So let's save, run one more time, and we should get a nice printout at the end of how long this took to run. 5.27 seconds. Great for 50 pages. Now moving on to, I guess, what people are going to find the most interesting. So if you've skipped across here, no problem. But we're going to make this async, and I'm going to show you just how quick this can be. But there is a couple of things that we need to think about first. Now, to create and to make this async is super easy, which is one of the things that I love so much. We don't have to mess around with anything. We can literally do this, true, like this. I get my brackets right. And then add in at the bottom here, c.wait. We want it after our visit because we want to do this. However, this is not actually going to change anything because we are basically we're only telling it one URL at a time, so it can't do it asynchronously. We need to give it a load of URLs to start with so we can actually make use of the time saved whilst we're waiting for requests to come back. We can make more. At the moment, we're just saying, here's a page, go there, and then it'll find another page, go there, find another page. It doesn't know that there are 50 pages, so we could either do visit and copy this down like 50 times. We definitely don't want to do that. But what we're going to do instead is we're actually going to change our approach ever so slightly. So as well as going for and grabbing the information which we need and going through the pages, what we're going to do is we're actually going to pull the information from this on the left hand side here, these categories. And that's where I think this becomes really good. If you're doing HTML scraping and you have loads of categories, or you can get loads of links to start with, making an async scraper with Go and Collie is super easy. So we need to grab all of this information and change our start URL. So to do that, we need to do, again, c.on.html, because we're going to be going to the first page and doing the HTML. And it is div.side categories, li, ul, li. This is why I love CSS selectors so much. Now from here, we want to say our link is going to be equal to, I'm doing this slightly differently, h.child attribute from the A, again, href, and then c.visit, the h.absolute URL. I'll request first, request.absolute URL on this link. So I've just put this across two different lines for the moment. But now what we're saying is that when we go to this first page, which I'm about to change, we're going to grab all of these links, which means we can make use of asynchronous here. So I'm going to make travel my start page because it's the top one. And we'll go down. We'll comment out this, paste that in, and save. Okay, so let's get rid of wait first, and let's make this not async. So we have a base starting number, save, run. We can see that we're going through all of the categories here, and some of them have extra pages, which we should see come up. There you go, you can see page, extra, whatever. 8.09 seconds to get all of that information. So now we can just redo our async, like so, and our c.wait, because we need to wait at the end, and let's run it again. You see all the links flash up like that. 1.67 seconds. So we've gone from 8 and a bit seconds to 1.6 to get the same information just by changing our approach ever so slightly and doing the c.wait and the collie.async is true. So if you like the look of async and you want to do it in Python, you absolutely can. You're going to want to watch this video right here.